Good day, everyone. I am Lian Marie Barranco of BSEC 3C, and for EC23 or Communications 2, we're going to discuss a TDM technology that is SONET in this performance task number 10. So, time division multiplexing or TDM is a technique for transmitting two or more signals over the same telephone line, radio channel, or other medium. Each signal is sent as a series of pulses or packets which are interleaved with those of the other signal or plural signals and transmitted as a continuous stream. So TDM is transmitted um, in a variety of means which can be in telephone lines or radio channel or any other consisting signals. TDM has a variety of technologies such as SONET, SS7, SDH, PDH, ATM, ISDN, and etc. But for this video, we are going to discuss about SONET or Synchronous Optical Network. SS7 stands for Signaling System 7. SDH is Synchronous Digital Hierarchy. SDH is often compared to SONET because they have similarities in their principles. Next is PDH, which means Plesiochronous Digital Hierarchy, ATM or Asynchronous Transfer Mode, and ISDN, which is Integrated Services Digital Network. So SONET, Synchronous Optical Network. It is a communication protocol that is developed by a telecommunications company, Bellcore, that is used to transmit a large amount of data over relatively large distances using optical fiber or fiber optic wires. With SONET, multiple digital data streams are transferred at the same time over the optical fiber. So these are the things that we need to know about SONET. It is developed by Bellcore, and this Bellcore used to be a telecommunications research and development company that provided joint R&D and standard setting for AT&T and its co-owners. But now it has a different name because the company that handles Bellcore are different. And SONET is used in North America. It is standardized by ANSI or the American National Standards Institute. So it is similar to SDH, that stands for Synchronous Digital Hierarchy, which is used in Europe and Japan. So if North America have SONET, in Japan and Europe they have SDH. So SONET, from its name, synchronous. The network is like a clock, or literally a single clock or primary reference clock (PRC), and it handles the timing of transmission of signals and equipments across the entire network. So this is the network elements of SONET. We have here the terminals which accepts the input, the STS multiplexer, the regenerator, the add-drop multiplexer, and another regenerator, and the STS demultiplexer. This is the output terminals. This represents the section, the line that connects two multiplexers, and the path, which is the end-to-end of the network. So first, STS stands for Synchronous Transport Signal, and the STS multiplexer or MUX multiplexes the input signal that is provided in the terminals. So this multiplexes the signals by the process of converting electrical signal to optical signal, and then it is moved into the regenerator. In the regenerator, it is a repeater that takes the optical signal that was multiplexed by our STS MUX and regenerates the signal by increasing the strength. Next is the add drop multiplexer. So this allows the addition or removal of a signal or signals from different sources. So it can add or remove signals. And another regenerator again that regenerates the signal by increasing its strength. And lastly, the STS demultiplexer. Synchronous transport signal demultiplexer demultiplexes the strength, and it does the opposite of the MUX process. So now it is from optical to electrical signal. And again, this section is a portion of the network that is connecting two neighboring devices. So these devices is the STS multiplexer and the regenerator. This portion is called the line portion, because it connects two multiplexers, the STS multiplexer and the add-drop multiplexer. And the path is the end-to-end portion of our network. Next is the layers of SONET. In the data link layer, we have the path, the line, and the section. In the physical layer, we have the photonic layer. So discussing about these layers, first is the path layer. This belongs to the data link layer. It is responsible for the movement of signals from its optical source to its optical destination. STS MUX demux provides path layer functions. Next is the line layer. It is responsible for the movement of signal across physical line. STS MUX demux and add-drop MUX provides line layer functions. Next is the section layer. It is responsible for the movement of signal across a physical section. Each device of network provides section layer Each device of network provides section layer functions. And lastly, the photonic layer that belongs to the physical layer. It corresponds to the physical layer of the OSI model. It includes physical specifications for the optical fiber channel with the presence of light that is equivalent to 1, where the absence of light is equivalent to 0. Now, the applications or where we use SONET. So, the standard STS1 SONET data path thus consists of 810 DS0 channels, of which 783 are used for data transmission, and 27 are used for framing, error correction, format identification, and other forms of overhead. STS1 is the electrical signal, and it is equivalent to OC1 or the optical carrier with the SONET speed of 51.48 Mbps. So STS means the synchronous transport signal, and OC means optical carrier. And also, SONET can be utilized to transmit and multiplex multiple data streams across a fiber optic cable. So for a summary, with the use of SONET, we can transmit data to long distances. SONET has low electromagnetic interference, and it is a synchronous transmission of voice, video, and data over long distances of usually fiber optic cabling. And here are the sources of the researches that I made for this report. Thank you.